Hello all, welcome back. Here the discussion is on heap data structure. We can use heap data structure to implement priority queue. And coming to the structure of heap, how the heap data structure appears means it is actually a tree data structure, okay, where it consists of nodes, and this tree data structure actually follows a binary tree data structure. Means it follows the properties of binary tree. So what is the property of binary tree? Binary tree property is each and every node in a binary tree should possess at least zero child node and at most two children node. So that is the property. Means so each and every node should have maximum two children, not more than two children. Okay, and minimum can be zero child. That is what the property. The same property heap is also following, and along with that heap also follows two more properties. So when you are constructing a heap data structure, so this heap follows two properties, that is complete binary tree property, and the next is heap order property. First we'll see what is complete binary tree property. Coming to complete binary tree property, always the new node that you're going to insert should be inserted at the last level of the tree. Okay, that is first the top level should be filled. So once the top level gets filled, and then you will be moving to the next level. So the next level should be filled, only then we can move to the second level. Okay, this is how the complete binary tree works. That is, you need to place the nodes, insert the nodes starting from the top level to the last level, and always insertion happens at the last level of the binary tree. Okay, and one more thing, the insertion happens from left towards right. Okay, for example, if I want to insert some values like 15, 20, 25. So how do I insert? First I have to insert it at the root. 15 should be inserted at the root. So once I insert it at the root, then I have to move to 20. Now coming to 20, we need to insert 20 to the left side of this tree. Okay, so this 20 should be inserted in the last level. That is, this is the last level for this tree now, and you have to start inserting it from the left. Okay, so first left child node should be filled. After filling left child node, you can go for the next right child node. Okay, so coming to the next value, which is 25, and this 25 should be placed at the right child node. Likewise, you need to construct the heap tree based on this complete binary tree property. And the second property is heap order property. So here heap order property depends on the types of heap. That is, there are two types of heap here. One is min heap and the next one is max heap. In min heap, the value of the root node should always be lesser than the children. Okay, so that is what the property of min heap. If you take min heap, the value of the root node, you can take this example here, the value of the root node is lesser than its children. So that is what min heap. When we take max heap, always the value of the root node should be greater than their children, or you can say the value of the parent node should always greater than their children. Okay, this is apply like this property should be applied for all the levels of the complete binary tree. So this is what the heap order property. When it is minimum heap, the root node value should be minimum than their children. When it is maximum heap, that is max heap, the root node value should be greater than their children. And if you take min tree, always min tree has the smallest element at the root node. And coming to max tree, always max tree contains the largest element at the root node. Here is an example for min heap and max heap. If you look at the min heap, so the maximum, like all the values of the min heap, how it is arranged, the minimum value, that is the smallest value among all these values, will be placed at the root node value. Same coming to max heap, the largest value is placed at the root. And if you check the property, it is following the complete binary tree property. Also, this minimum heap property is also followed, because if you compare 5 with the remaining elements of its child and grandchild, so this 5 is the smallest one. In the same way, if you compare 7 with its children 8 and 10, so 7 is the smallest. Coming to 9, same, it is smaller than 15 and 18. And in max heap also, compared with 18, all the other elements are lesser, and compared with 6, all the elements present at its child are smaller. In the same way, when you are going to construct a heap tree, you should follow this property. What are the operations we can perform with this heap is insert operation, delete operation, extract min or max, and heapify operation. So insert operation, we know we are going to insert a new value into a heap. And coming to deletion, deletion also means you are going to delete some element from the heap. And coming to extract min or max, so when you are going with min heap, there you will be extracting minimum value, and when we are going with max heap, there will be extracting maximum value. So how do we extract min and max, and where that min and max will be extracted, that we will discuss now. And the last one is heapify. So when we want to perform this heapify operation, whenever you are performing insert operation and whenever we are performing delete operation, there we need to check for the properties. That is two properties of heap. One is complete binary tree property and the second one is heap order property. So when these two properties are not satisfied, and especially the heap order property, when the heap order property is not satisfied, and in that point we'll be doing this heapify, okay, in order to satisfy that property. And here is the array representation of heap. So for this min heap, how do we do array representation, right? So I'll take this example and I'll show you how array representation of this min heap will be. Starting from the root node, okay. So here the first value, that is the root node value, should be placed at the index position 0. So here this is array representation, and we know the array position index value starts from 0 to n minus 1. So which means here 0, 1, 2, 3, 4, 5, 6. Right? So totally how many nodes are here? 1, 2, 3, 4, 5, 6, 7 nodes are there. So here we will be inserting 7 nodes. 7 nodes, and starting from the index 0 till 6. Now 5 will be placed at the index position 0, and coming to the next value 7 will be placed at 1, 9 will be placed at index position 2, and then 8, 10, 15, 18. So this is how the value gets placed into the array when we are going for this minimum heap. And coming to this maximum heap, how the values gets placed into the array. So starting with the first, that is root value 18, and then 6, right side 12, again 5, 4, 7 and 3. So this is how max heap elements of this heap data structure gets placed into the array. Okay, so starting from the index value 0 till 6, right? This is what the array representation. And now we'll see how to perform insert operation, that is how to construct a heap with some example. Here I have taken an example values like 7, 10, 25, 17, so on. Now we'll try to construct a simple heap, that is minimum heap with these values. Okay, so how does insert happens in a minimum heap? Starting from the first value 7. So as usual we will be inserting 7 at the root node. This is what step 1. Okay, inserting 7 at the root. And then what is the next value? We have 10. So where should we want to insert 10? I know, like I said, the first property is complete binary tree property, where insertion should happen at the last level starting from left towards right. Now this next step is we need to place 10, and that 10 should be placed here in level 1, okay, at the left hand side of 7. Right, after placing this value here, you need to check whether it is satisfying the heap order property. So since I have taken minimum heap, okay, min heap, always the root node value or the parent node value should be lesser than its children, and here 7 is the root node and the child node is 10. Comparing 7 with 10, so 7 is minimum. So here it is satisfying the property, so no need to do anything. Then moves to the next step, that is inserting 25. So where we will insert 25? We need to insert 25 towards the right of 7. So 25 will get inserted here. Again, after inserting 25, check for the properties, that is heap order property. Comparing 7 with its child node 25. Yes, 7 is minimum than 25, so keep it as it is. Now what is the next value to be inserted? The next value is 17. So where 17 should get inserted? 17 should get inserted at the last level starting from the left side. So what is the last level? Here already this level completed, because it is a binary tree. Only this node 7 can have 2 children, not more than 2 children. So the next value should be inserted in the next level, level 2, and from level 2 you need to start from the left side. So taking 10, and 10th left child will be 17, next value 17. So place 17 here. Now after placing 17, you need to compare this 17 and 10 first. Okay, so here the parent value, that is root value, here is 10. So this root value is lesser than this children, right, child value. So the property is satisfied again. If this property is satisfied, again no need to do anything, just go to the next step. Okay, insert the next value, that is 23. So where 23 will get inserted? Next 23 should get inserted at the right of 10. So already 17 here. Now we need to insert 23 to the right of 10, because it is a complete binary tree. Okay, after inserting 23, again compare 23 with 10. 10 is minimum. So since it is minimum heap, so this is satisfying the property, and keep as it is. Okay, now go for the next value. What is the next value? We have 27. Where 27 will get inserted? Again, you need to insert 27 to the left of 25 because already 2 nodes over. Now coming to the next node, that is 25. For 25, it can have 2 children and starting from left side. And what is the next node to be inserted? 27. So 27 will get inserted here to the left of 25. Again, compare 25 and 27. This 25 is minimum and it is satisfying the property. So don't do anything, leave as it is. And then what is the next step? Insert 16. So where 16 should be inserted? Last level and at the last position to the right of 25. Now 16 will get inserted here. So after inserting 16, now you need to compare the root node value. That is parent of 16 and this 16. Okay, what is parent of 16? 25. 25 is not lesser than 16. This is not satisfying the minimum heap property. If it is not satisfying the property, then here you need to perform this heapify operation. Okay, what we are doing here, we are performing heapify operation where we will be that is swapping these two values. Okay, what we are doing in this heapify operation, will be swapping this child node value and the parent node value because it is not satisfying the heap order property, that is minimum heap order property. So when you swap these two node values, okay, then what would be the structure, that is after swapping, what would be the structure of your heap tree? So after swapping here, it will be 16 and left side 27 as it is and right side we have swapped 16 with 25, right? So once you swap it, you can check again this 16. This is a parent node of 27 and 25 which is lesser than these two values. Okay, but here you cannot stop right here again. What you need to do is, since you swap these two values, again you need to compare this value to its parent node. Okay, whether the parent is satisfying the property or not. If the parent doesn't satisfy this property, again swap these two values. Okay, if you check this with 7, 7 is minimum, which is satisfying minimum heap order. So what you're doing, you're not doing anything here, just move to the next step, that is insert the next value. And coming here, what is the next value to be inserted? And the next value we need to insert is 19. So till 16 we have done with the insertion and now we need to insert 19. So where 19 should be inserted? At the last level starting from left side. So this is the last level and this is the left node value. So you have to place 19 here. Then compare this 19 with its parent. So it is satisfying the min heap property. Leave as it is. Then moving to the next value 37. Where 37 will get placed? Again at the last level and at the last position, that is right of 17. Okay, again compare 17 and 37. 17 is minimum, so leave as it is. And what is the next node? 42. And we need to place 42 towards left of 23. So 42. Compare 42 with 23. 23 is minimum, so it is satisfying the property. Leave as it is. And what is the next value? Last value we have here is 4. So where 4 should be placed? 4 should be placed at the right hand side of 23. So if you look at this 4, 4 is minimum than 23, which is not satisfying the property here, which is violating the minimum heap property. If it violates the property, what we need to do? You need to perform heapify operation. Okay, here you are performing heapify where you will be swapping these two values. If you swap these two values, then in place of 23, what we will get? In place of 23, we will get 4 and in place of 4, we will get 23. And here we are not going to stop with this like this step because also we need to compare the swapped values, right? So what you will be comparing now? You will be comparing this 4 with its parent. Okay, what is the parent? It is 10. Again, it is violating the property. If it violates the property, what you need to do? Again, perform the heapify operation. Okay, you need to swap this 4 and 10. So if you swap 4 and 10, here what you will get? 10 comes down and 4 goes here. Okay, now once again, you need to compare this 4 with its parent node. What is the parent of 4 now? It is 7. Okay, again compare these two values where 4 is less than this value 7, which is again violating the property. It is not satisfying the min heap property. In that case, again what you should do? You should swap these two values. That is, you are performing heapify operation again. Okay, perform heapify. If you perform heapify, then 4 will become the root node value and 7 becomes the left child and 16 will be the right child. And after swapping, this is your final heap data structure. And can we stop it here? No. Again, what you need to do, you need to check the remaining trees, that is subtrees also, you need to verify once again whether the parent node is having the minimum value than its children or not. Okay, so take 7 and compare it with its children, it is minimum. Take 17, compare it with its children, it is minimum. Take 10, compare it with its children, it is minimum. Same for 16. So everything is satisfying these two properties. One is complete binary tree property and the other property is heap order property, and in this case this is minimum heap. So minimum heap order property is also satisfied, and this is our final heap data structure, that is minimum heap data structure. So here we discussed about two operations. One is insert operation and the other one is heapify operation. Okay, and coming to deletion, how do we perform deletion? And before deletion, so we should know what is extract min or max. Okay, extract min or max means in minimum heap you are going to extract the minimum value, and extract max means in the max heap you are going to extract the max value. So we already discussed that always minimum heap has the smallest value at its root and maximum has the largest value at its root. So when you are extracting minimum value from heap, so we will be extracting the value that is present at the root of the minimum heap. This is what extracting minimum. Okay, and if you are extracting maximum, then we will extract the root node value of a max heap. That is what extracting maximum. And when you are performing deletion also, you can extract either the min or max, okay, based on the tree, and you will be performing deletion on that value only, either the smallest value or the largest value. So if it is minimum heap, you will delete the smallest value from the tree. If it is maximum heap, you will delete the largest value from the heap. This is how deletion happens. Okay, so we'll see one example for that. And for deletion, I'm taking the same min heap example. So here I want to perform deletion. If I am performing deletion on this min heap, so which node will be deleted? Obviously the root node will be deleted first, and this is what extracting min. Okay, you are extracting min in the minimum heap, right? And this minimum value will be deleted from the min heap. Okay, that is present at the root node of a min heap, that will be deleted. So if you delete this node, then how our if you delete the value from that node, then how will be the structure of the heap? What we will have in that heap data structure? Okay, that is tree. So after deleting 5, okay, this is my tree structure, and if you can see, and you can see here there is a node, okay, root node, which doesn't have any value because you deleted the value 5 here. It is empty now, and what you need to do is you need to replace some value in this node position. Okay, and which value can be replaced here? So when you are trying to replace the value in a heap, always go for the last value in the tree. Okay, what is the last value that is present in the tree? That is at the last level. Okay, and in this, what is the last level? This is the last level, and in this last level, what is the last node value? Which is 18. So what you need to do is you need to replace this value 18 here to the root. Okay, now 5 gets deleted, value 5 gets deleted, and after deleting 5, you need to replace this value with the last value of your tree data structure. And you can also see array representation. So for this array representation, if you take, so 18 will be at the last index position because this is a last node value, right? So this 18 will be placed at the last index position. So remember that when you are deleting the first value, then that value should be replaced with the last position value. Okay, so here we replaced this with 18. After replacing it, what you need to do? You need to check whether this satisfies the heap order property or not. Since we are dealing with the minimum heap, okay, it should satisfy the min heap property, right? And if you compare this 18 with this children, no, it is not satisfying the property because 18 is greater than its children. So here what you need to do, since it is not satisfying the property, you need to perform heapify operation again here. After performing deletion, you need to check whether it is satisfying the heap order property. If it is not satisfying, then go for applying heapify operation. So how do you apply heapify operation? Since we are performing min heap, you need to compare these two values. Among these two values, which is the minimum value? 7 is the minimum value. So replace this 7 with 18. That is swap 7 and 18. Okay, now 7 becomes the root node and 18 becomes the left child, 9 will be the right child. And to the left of 18 it is 8, to the right it is 10, and to the left of 9 it is 15. Right? So this is what the deletion, that is first value, deleting 5 from the min heap. After deleting 5 and after performing heapify operation, this will be your tree structure. So again what you need to do, after swapping these two values, you shouldn't stop here because again you need to check whether this is satisfying the property or not. If you check here, Again, this is violating the property because 18 is greater than both of its child node, right, children. So here again you need to check which is having minimum, which is the minimum value among these two children. So 8 is the minimum value. So swap 8 with 18. Swap 8 with 18. So you will get 8 here and 18 will be left side, right side 10. And here it is 15. Okay. So this is what the final heap data structure after deleting 5 and performing heapify operation. In the same way, next again you need to perform delete. So which node will be deleted? That is, which node value will be deleted? Again the root node value. What is the root node value? 7. So if 7 gets deleted, then after deleting 7, you need to replace that node with some value. So which node value we can choose to replace there? So what is the last value you have in your tree? 15 is the last value at the last level in the tree. So you have to replace this 15 with 7. So for 7, I am replacing it with 15. Right? Now after replacing it with 15, now what you need to do? Compare this with its children. If it is satisfying the property, fine, leave as it is. If it is not satisfying the property, again perform heapify operation. So here it is not satisfying the property, performing heapify, comparing two children first. So 8 is the minimum and swap 8 with 15. So 8 becomes the root node, 15 will be the left side, 9 will be right as it is, and then 18, 10. Right? Now after swapping also you need to compare this node with its children. So if you compare 15 with its children, again what happens? It is violating the property because 10 is lesser than 15. So again what you need to do? You need to perform heapify operation and swap these two values. If you swap, root will be 8 and here you will be swapping 15 with 10 and left side will be 18 and right side will be 15. Okay. So after this will be your final heap data structure, minimum heap tree. This is what the operations of heap.